Hello Python programmers. So this is the video 5th of our machine learning with Python video series, and in this video we're going to discuss one of the most important library of Python for machine learning, which is Numpy. So first of all, we'll start off with the theoretical part before moving ahead to our more practical explanation of Numpy commands. So first of all, I would like to explain you that what Numpy is. Numpy is a linear algebraic library of Python. Now let me explain you this in a more simpler language. Numpy is the library which is used for scientific computation in Python. Now, as you move ahead in this video and in this video series, you will understand more clearly that what scientific computation are we talking about here. So now the data used for machine learning is normally in the form of rows and columns, and if you know the basics of Python, you must be familiar that we have a data type called list, which is also capable to handle such type of data. So why do we need a external library such as NumPy? So the biggest advantage of NumPy over list is that it consumes very less space as compared to list. So as space required or memory required for storing same amount of data is less, the computation speed increases, and hence the efficiency of a machine learning model also increases. Now there are certain factors that affects this less space requirement for the same data in NumPy as compared to list. Like there is no type check in NumPy. Normally in list we check that what is the type of data, like whether it is string or integer or another list, but in NumPy we don't compare the data type. Second, it is having contiguous memory, and which leads to less memory requirement for a NumPy array. Now let's see how many type of NumPy array are there. There are two types of NumPy array. First is vector and the second is matrix. Vector is the one dimension array which is having one column only, and matrices are multi-dimension array, that is it can have multiple rows and multiple columns. So now we are done with our theoretical part. Now you must be familiar with the background of what NumPy is and why it is so important in machine learning. Now let's get to our Jupyter notebook. Now if you haven't used Jupyter notebook, I'll provide a video link below. You can watch that and get started with Jupyter notebook, and if you already know how Jupyter notebook works, then let's get started. Okay, so first of all let's install NumPy. Now if you have watched my previous video on pandas and you have installed pandas, then you don't need to install NumPy, because NumPy is the supporting library for pandas, so so it is also installed with pandas. But if you haven't, then just write pip install NumPy in your terminal and press enter, and this package will be installed for you. So let's start with our tutorial here. So first of all, let's start off with the things that you already know. Now you already know how to create a list. So this is simply a list of three integer values. If you just write the type of this A, and then you can see that it is a list. Now let's convert this list into a NumPy array. Let's create a variable NA, and actually we need to install NumPy first. So import numpy as np. I'm using a shorthand as np. Now na is equal to np dot array. This is what you have to write to create a numpy array, and just write the list name here. And np is not defined because we haven't executed this line. Okay, so now let's run this, and there you can see if we write na, then there you can see that this is a numpy array. And if we check the type of our array variable, then we can see that this is a numpy n dimension array. So from this we have created a vector, because as you know, a vector has only one column and it is single dimensional. So let's create a two-dimensional numpy array, or what we call a matrix. So we'll create a nb variable, and we'll write numpy dot array here, and we'll create our numpy array. Let's say 1 2 3 4. Let's run this. Actually there should be a list inside list. Let's run this now and see how our nb variable is looking. So there you can see a beautiful looking two-dimensional array having 1 2 3 and 4 columns and 3 rows. So now let's call out some of the commands in numpy which will automatically generate a numpy array for you. And our first command is numpy dot arrange. Just a second. np dot arrange, ARANGE. And this arrange command will have three parameters. First is the starting point, second is the ending point, and third is the difference between two consecutive numbers. So let me start off with a very simple array which will have starting point as 0 and ending point as 10. So let's print C here, and there you can see Python indexing starts from 0, and there you can see we want 10 elements in our array, so we are having 10 from 0 to 9. Now let me explain you with all the parameters. All the three parameters should be arranged here. Arrange, first is the starting value, let's say 1. Second is the ending value, let's say 10. It will go from 1 to 10. And then the difference between two consecutive number, if you write 2 here, then it will first go from 1 to 3 to 5, then 6, then 7. Let's run this and see what is our final output. There you can see 1 3 5 7 9. After the starting point, it's adding 2 to every consecutive number. Okay, so now let's see the second command which will automatically generate the numpy array for you, and it is called line space, which is very similar to our arrange command, but is having only one difference. The first parameter is the starting point, second is the ending point, very similar to our arrange, but there is a difference in our third parameter. Third parameter is the number of evenly spaced integer from the starting to the ending point. Let's say that we have specified 1 as our starting point and 10 as our ending point. So if we write any number here, let's say 5, so it will divide 1 to 10 into 5 equally spaced sections. So let me run this and show you. It should be linspace. Actually it should be linspace here. Let's run this, and if we run our d variable, you can see that we are having 5 values: 1, 2, 3, 4, 5. So what this linspace command has done is it has broken down our 1 to 10 number line into 5 equally spaced intervals. Okay, so now moving ahead to some of the small numpy commands. First is how to get the size. So we'll simply write size. It will show you the rows into column. Let me create a multi-dimensional array. Actually we have already created, so let's see that what is the size of this one. There you can see 12, because we are having 1 2 3 4 columns. We are having 4 columns and 3 rows, so 4 into 3 is 12. If you want to get the exact number of rows and columns, that what you can do is you can write shape here and then run this shell, and there you can see 3 is to 4. 3 is the number of rows and 4 is the number of columns. Now what if you want to create a numpy array of all zeros? So what you can do is you can simply write np.zeros. First we'll create a vector of a specific number of elements, let's say 6. So it will create a numpy vector of 6 elements. Then let's create a numpy array or a numpy matrix of, let's say, 5 is to 6. So what you need to do is you need to provide a tuple inside. Let's say we want to create for 3 is to 4, so you'll simply write 3 is to 4 inside, and there you can see 3 is the number of rows and 4 is the number of columns. Now let's create the numpy array of all ones. So what you can do is, similar to zeros, if you want to create a vector, just provide the value here, and if you want to create a matrix, then again a tuple inside, not 2 tuple, only 1 tuple inside, 1 tuple inside, and then the shape of your matrix. That you can see it will create a matrix of all ones. Okay, so now coming off to our next commands, which is how to generate a random array. Now many times when you want to practice on NumPy, you want to generate some random array. Either you want to work on NumPy, or you want to work on matplotlib or on pandas. You just don't want to waste time to just create an array. You just want that a random array is generated for you. So NumPy is taking care of that also. Let's create a variable, let's say f, and we'll write np.random and press a dot and press tab here. It will give you a bunch of methods that you can use to create a random NumPy array. I'll show you some of the very common ones. First is np.random.rand, rand, and then provide the length similar to our ones and zeros. If you want to create a vector, you will simply provide the value here. Let us print this one. Okay, you will provide the value here, and if you want to create a matrix, then insert a tuple for the size of your matrix. Okay, tuple object actually this random will not be accepting a tuple. You will only provide the value here. Okay, so I was wrong here. So you just provide the value here if you want to create a vector or you want to create a matrix. Now the second command used to create the random array is random.randint. Random.randint. Just a second. So what random.randint accepts as a parameter is first your starting value, then then is your ending value, and then the number of random numbers that you want to insert, let's say 20. So from 0 to 100 we want to extract 20 numbers, or we want a array of the size 20 having random numbers between 0 to 100. So let's print out this f variable. So there you can see having 20 elements in a vector having random values between 0 to 100. Now what if you want to know that what is the maximum minimum value which is present in your numpy array? So you can simply write f.max and just run this, and there you can see 93 is the highest value present in this array. Now this array may vary because these are the randomly generated number. This may vary from me to yours to the person seeing this video. Now if you want to see the minimum values, just write f.min, run this, and there you can see 0 is the minimum value. And if you want to know the index at which the maximum or the minimum value is located, then you just need to write arg of the max and just run this command, and at the 14th index our maximum value is located. And let's see for the minimum one, and minimum one is located at the 4th index. Okay, so now let's say you want to reshape a numpy array. Now we have randomly generated this numpy array f, but it is a vector. What if we want to convert this into a specific matrix of a specific shape, let's say 4:5? So what we can do is we'll write simply f.reshape, the variable having that array f reshape, and then the size m 4:5. Make sure that the number of elements in your array 1, which is your previous array, and the array 2 that you are gonna create is the same. There you can see. But what if I mess up with the value and want to create a numpy array of a element of greater size, like it is having 20 values but I want to create for 40 value, maybe some typing error. So what the error will display is cannot reshape array of size 20 into the shape 4:10, because the total values required or the total items required for this type of array is 40, but the total number of elements present in our f array is only 20. So we'll make this 5 here. You can try any combination, but the total number of elements should be the same as the previous one. There you can see 2:10. You can even write 10:2. So you can just experiment with this value, and I want you to experiment with all these value. I'll provide this notebook in the in my GitHub repository. The link will be provided below. You can just experiment with these values, because this is how you will learn. Now I'm creating this video in in as depth for NumPy as possible, but it is impossible to cover up all the commands. So it is your task to practice and discover new commands, because I may create a video and explain you many stuffs, but it is useless if you don't practice. So I will provide this notebook in the GitHub repository. Link will be below. You can download this and work on this notebook and just explore what NumPy is and what commands the NumPy is having. I will also provide a link which will have all the commands that you should know or that are present for NumPy. Actually, that is the documentation of NumPy. This is the documentation of NumPy. I'll provide the link below, and there you can see there are like thousands of commands, thousands of methods that you can use in NumPy. So I'll provide the link below. If you are curious enough, you can explore this link. Okay, now let's move ahead to one of the most important topic for NumPy array, which is indexing. So first of all, we'll start off with the indexing of vector. So let's consider a array. Let's consider the F array. So let us first print here, so it's more convenient for us to see. Now what if you want to extract a specific value from your NumPy array? You will simply provide the indexing, which is very similar to how the list works. So you'll provide 10 here, and if we run this, you can see 5, which is present at the index 10. Now let us check. 0 1 2 3 4 5 6 7 8 9 and 10. There you can see. Okay, now what if you want to extract a range of values, let's say from the index 5 to the index 15? So what you can simply write here is f of the index starting point and of the index ending point. Let's run this, and there you can see this is the array subset that we have extracted. Okay, so now what if you want to change the values of some certain elements to a desired value? Let's say that you want to change the values of first 5 elements to be, let's say, 6. I haven't closed the brackets, equal to 6. So let's run this. No error. Let's run our f variable, and there you can see the first 5 value has been changed to the value 6. Now let me show you the example of a very important property of NumPy, which says that if we take a slice from the array and make some changes to it, the original array is also changed. Now this is very effective because we aren't making unnecessary copy and occupying a lot of space, because the dataset used for machine learning are very huge, and if we keep on creating multiple copies of that, then our program will be just laggish and it will slow down ultimately. So let me show you the example of this. Let's create a f variable which will have a sub array from our f array, let's say up to 4 values. Let's run this, and now if we change all the elements of this g sub array to, let's say, 10, and let's see how our g array is looking. There you can see g array, and now let's see that how our f array is looking. There you can see the change is also made on our original array. So this was the example depicting you the property of NumPy, that it doesn't allow unnecessary copying of the NumPy array. Now what if you genuinely want to create a copy? So what you'll do is, let's create a variable, let's say copy f. What you will simply do is you'll write f dot copy. So what it will do is it will create a copy, and if you make any changes to this array, it will not affect your original numpy array. Now this can be used for testing if you don't want to make any changes to your original array. Let me show you that it isn't making any change. Let's say that copy of f to the index 10 is equal to 15. Now let's print our copy f array, and there you can see the first 10 elements have been changed to 15. Now let's run this code and see how our f array is looking. There you can see no changes is made in our f array. So this is how you can create a copy of your existing array. Now we have done enough for our 1D array. Let's work on 2D arrays. So I guess we have created a random 2D array somewhere above. Just a second. There you can see we have created an array with the name nb, so we'll use that one only. To be convenient, I'll print this out here. This is your numpy array. And what if you want to do slicing? So if you want to print the first row, actually the second row, because indexing of Python starts with 0. So n is not defined because there should be nb. Okay, nb1, there you can see it's showing the second row. Now what if you want to extract a specific element from a specific row and column? Now there are two methods to do this. First is the 2 bracket method, and the second is 1 bracket method. So the 2 bracket method uses 2 brackets. Very genius. So let's say that you want to extract from the first row and the second column. So there you can see 7th, because from the first row, and 0 first and second column. Okay, now let's see our second method, the single bracket method. In this you will write the row and column values separated by a comma. Now for those who are confused here, the first value is the row and the second value is the column. Okay, so let's run this, and there you can see 7, similar value. Okay, so what if you want to extract a sub array or a small section of array from a existing array? Let's say that you want to extract all the columns from this row, the which is present at the 0th index. So what you will do is you will simply write okay, so it will extract from 0, from 1, actually from 0 to 1, so it will only extract 0, and then we want to extract all the let me write, then I will explain you. So if we run this, there you can see we have extracted our first value here. To make this difference visible, let me take some other values. Let's say that you want to extract the second row which is at the index first. So what you will simply do is you will write from the index 1 to the index 2. What it will do is it will take the first index only, because in slicing we don't consider the second value, and then the column. So we want all the columns, so we'll write just a semicolon here. There you can see we have extracted the uh, second row. Now what if you want to extract both of the rows from the bottom? So what you can do is you will write 1:3 and all the columns here, and there you can see you have extracted both the rows. What if you want to extract only the last two columns? You want to extract only last two columns. So what you will do is you will start off from first, then you will go to fourth. 0 1 2 3, actually it will be 3 only. So there you can see we have extracted the last two. Actually we haven't extracted the last two, we have extracted the middle ones. Go from 2 to 4, and there you can see we have extracted the last ones here. So you won't understand if you are not practicing along with me. This is not a history class that you are listening to a lecture. You will learn programming only by practicing. So I would insist you to download the notebook and just practice on that. Now let's move ahead, and this is one of the most important command, and we'll be using this a lot, which is called the comparison within an array. So how it works is we will compare our array with a certain condition. Let's say that we want to extract all the elements which are present in this F array which are greater than 10. F array which are greater than 10. So let's run this, and there you can see these are the only values which are present in this F array which are greater than 10. Now let me break this down and show you how actually this is working. Now we'll create a G variable, and let's say that G is equal to G greater than 10. Just a second, and let me print G here. Okay, so I guess we have already created a variable G. Okay, so G is equal to F or greater than this, and there you can see this is showing the Boolean array having a true value for those who are greater than 10 and false for those who are less than 10. And what you can do is you can just write this FG, and it will only print out those which are having true values. So this is how the conditional is working. You can use greater than, less than, greater than, equal to, less than, equal to signs here. Okay, so now moving forward, we will discuss that how you can perform mathematical operations on a numpy array. Now numpy array treats every elements as a unit, so if you perform any operation on a numpy array, all the units are treated equally. Let me explain you what I mean here. Let's use this F array only, this F array, and what we'll do is we will add F with a certain value, let's say 10. Now pay attention to the values which are present in this F array. There you can see all the elements of this F array is added with 10 static value. Okay, so now let's see what if you want to add two arrays, F plus F. Now the two arrays that you are adding must be of the same size. So there you can see 10 plus 10, 20, and there you can see all the elements are added with the second array's element of the same index. Now moving ahead, you can perform multiple operations, like you can do f into f, multiplication. There you can see you can do f by f. There you can see, because it's similar, this is why it will show you uh, all ones. Now to show you a very good property of numpy, let us create a new numpy array. Let's say q, and q is equal to np dot arrange, and we'll create of the range 10. Okay, now let's do q by q. Now there is a interesting output. There you can see it's showing a warning, not an error. It's showing a warning that invalid value encountered in truly divisible, because we cannot divide a number by 0. This is what we are doing here. If we print q, then there you can see the first value is 0, so 0 by 0 is not defined, and this is why it's showing nan, and instead of showing an error, it's showing a warning. You can see similar result if you do log, just a second, log of this q array. There you can see the log of 0 is minus infinity, but it is not showing an error, it is showing a warning. So you can do a lot of things more with numpy, like you can find out the square root of all the elements present in an array. You can find the standard deviation. You can find many things using this numpy. If you want to explore this, you can just go to this website, and you will find this under, I guess, universal functions. Yes, you will find this under ufunc heading. All the commands like square root, log, and log to the base 10, all the values you will find here. If I scroll down a little bit, okay, let me scroll down. There you can see you can find the mod, you can find the power, remainder, log to the base 10, log to the base 2, and you can do many things using this numpy package. So, and it is impossible for me to fit all these commands into one single video, and it is useless, because even if I create a video of all the packages, it's useless if you won't practice. So practice. This is what programming is. So this is it for this video, and I will meet you in my next lecture. Bye bye.